So in this case we're talking about things like a 20% increase in cyclone intensity. Now they're major changes, and I'll show you what a 20% means in terms of insured cost and loss. Increased in storm and tidal surges, so a 1 in 100 year event becomes a 1 in 17 year event. Increase in tropical diseases and pests. As the climate warms up, you get a lot of those tropical incidents of dengue fever and Ross River fever migrating further south. Needs to be balanced about where the rain falls and how often it falls, but you end up with these pulses and decline in that. And 84% of 57 endangered Australian animals lose critical habitat by 1 degree. Now, I spoke about minor changes in wind speed. In this case, the graph just shows 3 cyclones which have been retrospectively modelled, that if you cranked up the wind speed by 5%, 10% or 15%, what would be the change in the value of the damage? And you can see there that it has more than doubled with a 15% increase, and we're talking about a 25% increase. So you can see that the insurance companies are well and truly out there starting to plot and scheme as to where they'll insure and where they won't insure. Florida coastline is a classic example where they will no longer insure because of the losses. So what are some of these early manifestations? I could put pages and pages of this up there and you could bore yourself ad nauseum with it, but it goes on forever. A couple of big one-liners there: the loss of the Larsen B ice shelf in the Antarctica in 2001. It was expected to take decades to go, and it only took a few years. There's a nice little one for you that'll drive home to you the importance of climate change at a global level. The UN report that 67% of the glaciers in the Himalayas have gone in the last 30 years, and that those glaciers, while they're melting, it's not a problem, but they supply 40% of the globe's population with water. The meltwater of the Greenland ice shed now equals the Nile's annual flow, and so ad infinitum. I spoke about the rate of change being double what was expected, and here is a bit of a dramatic photo which is a reflection of the Antarctic sea ice in the summer extent. They projected that it would fall within this envelope, this grey envelope, with a confidence of most likely development within the darker grey, and the red line being the average expected or the mean. This is the real data. So the rate of melt has been more than double that was modelled, and they were fairly confident in that modelling. In Australia, just to cut to Australia, in 2003 we had a very dry year. 62% of Australia was drought declared. 23 of the 28 basins in Victoria were under restrictions. 80%, I was sitting around the Queensland Government at that stage with the DNRM and Treasury and Premier's Department talking about the fact that 80% of Queensland towns, that's not the population, had severe water shortages, and at that stage it was either late January or early February, and we were talking about those towns running out of water by June. So you can see that we can be quite exposed in relatively short periods of time. Anyway, it rained. But here are just some examples of some last year's and this year's sort of phenomena. You saw the bushfires. Well, not only did the bushfires kill 180 plus people, but more than double that died from heat-related diseases in both Adelaide and Melbourne that didn't reach the media. Record floods in the Herbert River, record temperatures in winter for Brisbane, 36 degrees. At the same time, snow was falling in Thredbo, and of course you heard today's temperature announcement for Adelaide. I want to talk very briefly about the implications for agriculture, and these will be dealt with in a lot more detail in a few minutes, but the implications occur in soil erosion, production, vegetation and biodiversity, water quality, and pests and weeds. So let's have a look at that. The interaction between variable rainfall means that you'll have extended periods of time without ground cover, and that will lead to quite substantial wind erosion, and so increase in those wind erosion events that you saw recently. And that water erosion, when they become high intensity events with very little ground cover, will result in quite a substantial soil loss. You saw that in Claremont a couple of years ago in 1991, whatever it was. The floods in Charleville saw metres of soil stripped from paddocks that were well vegetated. Desertification, will move east, fairly self-explanatory. The salinity levels for most of the semi-arid areas will decline by way of problem because of reduced soil moisture. Soil carbon loss will be totally dependent on management, and that will be dealt with at length in today's discussion, so we won't deal with it now. fertility will continue to decline if it's organically driven and the paddocks aren't well managed, and you'll get more variability in crop production. Flooding, saltwater intrusion will occur down the eastern seaboard as the groundwater on the eastern seaboard starts to contract. The saltwater will come in, particularly a problem for some of the islands. Effects on landscape hydrology, so you'll see major changes to the quality and the quantity of the water that's in your rivers, and there'll be these peaks and troughs in terms of the outbreak of major endemic pests and diseases such as ticks and bogus. And of course heat stress in animal husbandry is an issue to consider as well. Feedlot trials show that animals usually don't change live weight gain with increased temperature or exposure to hot days, but you know yourself that if you sit out in the sun it feels pretty uncomfortable versus a nice shady tree. So you just need to factor that in for thinking about the future. Changes in biodiversity we've covered, changes in fire regimes we've covered. There'll be a transition from cropping to grazing. It's already occurring in the Claremont and west of Roma areas, quite marked. And the changes in assimilation in CO2, that's a CO2 fertilisation, but it's also got to be linked with the fact that the rainfall is declining in many areas, and that will more than offset any change in productivity. Water quality and quantity will decline quite markedly as you end up with lots of stagnant ponds in rivers that become highly eutrophied, and you get blue-green algae outbreaks, very evident in New South Wales and throughout Queensland now. Flooding, those extreme events, more extreme events are likely, and you're going to see under COAG reforms, so the water quality reforms or water trading reforms, not only will water be traded, but there will also be quite substantial allocations made for environmental needs as well. So the competition and value of water will increase quite markedly. The water availability in terms of stock and water and irrigation is going to change quite markedly. We've seen evidence of that already. Demand increasing but supply rapidly declining. Very evident in the Murray-Darling, of course. Wetlands. Sorry, did I hear? Thank you. Wetlands and associated habitats, ponded pastures, you're going to see a lot of those areas that you were able to perhaps send your store cattle over to finish are going to suffer substantially in terms of the loss of those opportunities for cattle fattening. And the temperature I've spoken about, the blue-green algae. Water recycling will become a state-of-the-art business opportunity. That's just some rainfall from properties already, just where they've got decent data sets and I've been able to map it. You can see the same rate of decline that was evident from those earlier graphs. Pests and weeds, distribution and invasion patterns will change quite substantially. You might find the tick line moves a lot further south and then periodically will come a lot further north. So you'll find quite significant changes in those. You'll see changes in the distribution of weeds, but quite substantially for the croppers you'll see very substantial changes in biocontrol systems. So the implications, so how do you look at this in terms of a policy and institutional setting? I think we've already dealt with the issue of the adequacy of the existing storages to cope with the increased variability, but some of the other issues are the vulnerability of your own industry to water shortages, and particularly industry restructuring in the marginal areas, and what that will mean in terms of the policy and institutional settings such as exceptional circumstances, RAS and drought assistance schemes may be totally inappropriate. So I'd encourage you to be proactively involved in thinking about what your needs are for the future and how you can influence the policy setting agenda.